Okay, good afternoon. Welcome to
Calculus 14.
Calculus 14. So we're going to review, like we've talked about this shape before, but we're going to review a little 3D printing we've done with volumes of revolution. So tell me about this shape.
So this shape is, I believe, this is y equals sine x from 0 to pi,
Okay.
rotated around the x-axis.
Rotate around the x-axis. So we'll have a graph that looks like this. Am I on?
Yep, you're fine.
Okay, so y equals sine x. And this is rotated around the axis. This marker's, as usual, not great, but why don't you, so explain how you would find the volume of this. This is, in terms of, rotation and volume problems, this is a relatively straightforward one.
Well, so when you rotate around the x-axis, you can chop this y equals sine x up into a bunch of lines that when you rotate around the x-axis are going to become a bunch of circles.
Okay.
And now we can describe the radius of a point. We go at x distance. The radius of the circle is going to be the y value, which is sine x.
Okay. Just in case your marker dies, I got a green one working nearby.
So the area is the integral, actually pi times the integral, we can keep the pi on the outside, from 0 to pi in this case, of sine squared x dx.
Okay.
Because they're pi times the radius squared.
That's very good. And this is actually not a trivial trig integral. Do you remember what you do on sine squared?
I believe you want to look at what I think cosine of 2x is.
All right.
Which is, I think it's 2 cosine x sine x. No, it's, I'm not remember what cosine 2x is. I can find that out pretty easily. It's cosine, use the trig sum, cosine x times cosine x of cosine squared x minus sine squared x.
Okay, very good. So it's cosine squared x minus sine squared x. Nice. Good.
And then,
good figuring out too, by the way. Switch to the green marker. So what is sine squared x? Well, first of all, you have to translate this just into only sine squareds.
so cosine 2x. So cosine squared x is 1 minus sine squared x. So 1 minus 2 sine squared x.
Very good. So what is sine squared?
Sine squared, I'm going to erase this. So sine squared is going to be is 1 minus cosine 2x over 2.
All right, very good. So we're doing the integral from 0 to pi now. Pi times the integral from 0 to pi of 1 minus cosine 2x over 2.
Yep.
All right, so go ahead and write that integral. Be careful, sine squared is that.
Oh, so we don't actually need to square this.
Yeah.
Alright.
Alright, now, surprisingly, this is an integral that you can actually probably evaluate in your head by breaking it into the two pieces. So, what's the integral from 0 to pi of a half?
It's x over 2. X over 2 evaluated is 0 to pi.
Okay.
So which is pi over 2.
Alright, so that's times pi, so that produces a pi squared over 2.
Oh, okay. Do it that way. Pi squared over 2.
And then the integral from 0 to pi of cosine of 2x. So let's forget that it's negative for a second. The integral from 0 to pi of cosine 2x. What does that? What do you think that entails?
Well,
And why am I saying you can figure that out in your head without having to do a lot of calculating?
cosine's integral is pretty easy.
Okay.
It's just sine.
Sure, but let's think about it in terms of area.
Well, so cosine 2x is like cosine x, but just smushed.
Right. And so this would look like cosine x from what to what? From 0 to where?
0 to pi over 2.
Explain that to me.
Well, cosine x. Actually, no, it's the other way. Cosine 2x from 0 to pi is going to be the same as cosine x from 0 to 2 pi. Because
Why?
when you plug in pi to this, you get cosine 2 pi.
Okay. And so what's the integral from 0 to 2 pi of cosine x?
So,
Okay, that's fine. Just throw it.
I think it's a bad drawing, but I think it is. I think it's 0.
Okay. It's one cycle of the cosine.
Mhm.
So it's 0. So this integral is just evaluates to be pi squared over 2. So this is the volume of this shape is pi squared over 2. Pretty cool.
Mm-hmm.